Coming up to the final talk this evening, and it's titled, What Travelling Taught Me About Memory. Now, the speaker is, as you could probably guess, a quite seasoned traveller. He spent no less than 7 years studying abroad in places such as Auckland, Sydney and Boston, and he managed to get time to finish his PhD here in Oslo as a part of the LCBC group. My brain always wants to say ACDC. It's the LCBC group, and it's in Norway, the Lifespan Changes in Brain and Cognition, our department. That is, he didn't really stay in Oslo for a full PhD term, but spent parts of it at Harvard Medical School as a Fulbright Fellow. Today, he's working as a postdoctor fellow, still at LCBC, and his focus is brain development and the prevalence of Alzheimer markers in healthy adults. So please welcome Andreas Berg Storsve.
Thank you. This is a personal journey in places and also experimental paradigms. After my army service, I wanted to go somewhere nice, somewhere new, somewhere warm, but unfortunately I chose to go to Auckland in New Zealand, which turned out to be even colder, and the winters were a lot worse than in Norway. However, Auckland was a great place to start off as a psychology student because they have a very strong experimental tradition there. So it sort of laid down the groundwork for a lot of the stuff that I've been doing ever since. And especially they do a lot of experimental procedures on animals and a lot of operant conditioning experiments on pigeons. I didn't work with this guy, but he is very close to my heart, Mr. Skinner, or Professor Skinner. I actually got to hold the pigeon as well and lose a pigeon. It flew away, I had to find it again. But that only motivated me more. And what I learned is that simple stimulus-response associations are really powerful. So behavior is a really powerful way of understanding, for example, memory. And we know that a lot of the operant conditioning paradigms and also some of the reinforcement schedules can tell us something about the way humans interact with their environment. And so I got really interested in that, but I wanted to go deeper, so I wanted to understand what happens in the brain. Unfortunately, a pigeon brain is a bit of a mess. So I had to find a model system, so a brain as a system, a model brain that can be used to understand human psychology to a much greater extent. So then I chose to go to this place, and I stayed there for 6 years or something. And Sydney has a lot of really great labs in learning theory. And learning theory involves understanding how associations are implemented in the brain. We use rats, and in my case, we didn't use a cheese, we used a shock to do aversive conditioning on rats to try and understand human anxiety disorders to a greater extent. And what we found is that a lot of the things that we learn about animal classical conditioning and animal fear responses is applicable to human anxiety disorders. So it's a very powerful tool for isolating the variables and understanding actually what are the mental representations that we have to understand in order to understand anxiety. So we did a lot of extinction training on rats. So we paired some neutral and aversive stimuli, and then we tried to extinguish it. And what we found is that younger animals are a lot better at extinguishing fear than older animals. And also, there are actual mental representations. So these associations aren't just simple, they are actually cognitive constructs. That got me interested in cognition, and it also got me interested in developmental processes. So I decided to go back to Norway, to the LCBC group, which have a very strong developmental tradition, and who uses humans as their research subjects. And at some point, you have to put the human back into human research. And so this was a great opportunity for me to learn about the human brain and also about how the brain changes as we age. And it actually changes quite a bit. For example, when you grow towards 60, there's a lot of things happening. This is first just a slide showing average changes in the adult brain from age 20 to age around 90. So you can see the blue areas are actually decreasing, and so everything is decreasing. So this is the cortex. So the thickness changes, the area changes, and thus the volume changes. However, there are some areas that changes more. Some very sensitive areas. Some areas are very sensitive to aging. For example, in the bottom row there, you can see the entorhinal cortex and the temporal lobes, which are really important for memory. They show an accelerated change as we age. However, some people, they change less. And we need to understand why some people change less and some people change more. And we've done some studies on lifestyle factors that might affect this change. And for example, for BMI, which is one of several that we do, you can see that in many of the memory-related areas, there is an increased rate of atrophy. If you have a BMI over 25, then there is a relationship between higher BMI and more cortical atrophy. Same with sleep. You can see that less sleep is associated with an increased amount of cortical thinning in areas that we know are important for memory. So in a sense, to some extent, we can be the masters of our own fate. But we have to, of course, dig deeper into this. So we have all these memory areas, but they have to be connected. And the tissue that connects the different cortical areas that we know are important for memory is called white matter. And so I went to the US to learn more about reconstructing white matter tracts in the adult brain. And it's a really great place to be, and it's the people that actually develops the software that we use called FreeSurfer. And so when I went there, I collaborated with the developers, and I started simulating or statistically estimating the white matter tracts of our subjects. And this is actually one of our subjects. So this is some of the major white matter tracts in one of our research subjects. Isn't it so beautiful? Yes. And we actually found that episodic memories, as we would expect, changes in episodic memory across life are associated with the integrity of the white matter tracts. So by that time, I'd put the human back into human research and also learned something about the structure of memory in humans. And this is the group. So my advice to you is go out, meet the people that actually do this research, and find your own place. I found mine there. You might find it somewhere else. But it's really important to go out and interact and actually be there for yourself and experience it. And you will never regret that, I promise you.